back to J Club, and today we'll be focusing on a rather peculiar question. What is the 9,999,999th number in the pattern below? So it should be 1, 10, 19, 28, 37, 46, 55, 64, 73, 82, 91, 100, and so on. So in this video, we're gonna be focusing on the patterns behind this. Pretty easy to recognize. The formula to solve this question, and after that, as a conclusion, we'll also be covering the algebraic equation and what it exactly means and is all about. So firstly, when you first look at this question, it just looks like a wall that you could bump into and you say, ouch, ouch, ouch. What was that? And you don't know anything. But notice that the pattern below is pretty easy. So 1 to 10 to 19. Okay, this is hopeless. This is not what we want. Okay, for example, 1. There's 1, there's 10, there's 19. Okay, so let's just put the first 3 digits of the pattern. So 1 to 10 is 9, difference of 9. 10 to 19 is also a difference of 9. Okay, so that means the pattern is basically plus 9. But then the tricky part in this question is that it's the 9,999,999 number. If we said, what is the, for example, this is 10, 12. What is the 13th number in the pattern below? We can just say 109 because it's 100 plus 9. The thing is, we're asking for the 9,999,999 number, which is a zany number to come up with. And we need a certain way or formula to analyze and completely digest this question so that we can find the answer to, the answer. So, this is the formula. If we say, for example, we can say that I'm not sure if we can write in subscript here, but never mind that. It's like oops, sorry about that. AN. AN equals, I'll explain this later, A1. Okay, this is supposed to be subscript, but I can't write that. N minus 1. This is the formula. So what is A, N, and D? Well, the D is basically the pattern of this the number that is added to each number. So it's like 9, basically 9, because for our number it's 1, 10, and 19, whatever it is. So so 9 should be the answer to D, and A is basically the starting number, like the positioning number, so it's 1. So A is 1, and A is 1 here too. We can pretty much say that A equals 1. This is also what we call algebra, because we use variables and letters to symbolize such numbers so that we can use it in different variables. Covering that later. And finally, D is the number adding, so it's supposed to be 9. So we pretty much have AND here. and is and. Okay, whatever. So A1. So I mean that means 1A, right? 1A plus D. That's 9. That's 10. Now N. What's N? N is basically the number it's asking in the question. So N is pretty much what we call, what is it? 9,999,999. Such a big number. Yes, we got it. So, what do we do here? That means AN, that means A and N together equals A1, that means 1 basically, plus D, N minus 1. So D, so there's, what this bracket does is that it symbolizes how much D's are there by the bracket's amount. So that should be N 9,999,991 minus 1, so that should be 9,999,998. Pretty simple here so far. So that should be it. And plus D. So D, 9,998,998 nines. So we can use the help of our calculator to calculate this. No, that is not correct. How do you delete things? Again, I forgot. 9,999,998 times 9. So that should be a total of 999,999 times 9 equals, that should be 89,999,982. So we got this amount, and we can just label this amount as X. We can say X equals D times N minus 1. So it's basically this. Yes. And actually, since we don't have this, we just say this one. Yes. And we can say, yes, X equals, so we now have and X. I don't know how is that a word. So we already found out that X is now a total of around 89,982. So with our help of X, we can say the formula is also equal to plus X. So A1 is just 1. 1 plus X is 89,999,983. 89,999,983. Which is the answer. And to prove this correctly, equals, yep. To prove this correctly, let's do it in a smaller number. Now let's say 1, 2, 3, 4, 5, 6, and say we don't know what's the pattern because the number's too big. Ugh. And we're asking for the 7th pattern. Let's use this method to solve it. Now, AN was D. I just want to do the simple way. N minus 1. So, with this method, we can say A1. So, A is 1, of course. Actually, let's say. So, in here, A equals 1. And then D equals 1 again, because it's plus 1 every time. And then N equals to pretty much, it's asking for the 7th pattern, so it's N equals 7. Okay, and we're not forming an AND here. And then we have to solve for X to get the answer. X equals D n minus 1, basically. So we have a 1, that's 1, 1 plus D n minus 1. So that should be D1 n minus 1. So that should be 6, 1, 6 plus 1. So what we get is that A1, there's 1A, which is basically 1 because 1, 1 is 1. Now 1 here, and then plus D. That is the amount of n minus 1. So n is here 7 minus 1, 6. D equals 1. So it's basically 1, 6, which is 6. 6 plus 1 is, well, we have 7. And pretty much that's the answer, 7. So with this method, we can actually say that the answer is 89,999,983. Does that make sense to you? Because that actually does. And we can try this in any number as long as the pattern is only inclusive in one certain sequential theme that is included in every single form of number in the sequence or pattern. So that's pretty much algebraic equations. In math, of course, when you say algebraic equations, it can be x, y, or z, but it can also be things like d and d, n, a, whatever. Or whatever. There's lots of things. DNA. And there's also algebraic variables. These are what we call variables, to store numbers that we can use for later on, so that we can make questions more comprehensive and much more easier to understand. And that is why algebraic equations, in my opinion, are very crucial and very essential in mathematics, and also in ways of thinking, in ways of numerical thinking, and how to solve questions in such mathematical sort of that kind of way, to conquer questions, grab them in your brain, and just dive right into it and, well, get the answer to this question. So the answer to this question is 89,999,993. I think that. Yeah. Thank you very much.